So you have the screen now, right?
Yes.
Awesome, thank you. So thank you so much for reminding me that. So I'm going to go back to the main page to show you Python. Good that I was talking about mostly on the interface that you already see the modules and the information I was talking. But moving forward, then now you have my screen shared, you can see it. So python.org is the website that you basically go to get all the documentations and downloads and everything. Under the download, you can see Python 3.8.5 is available currently, that they're working on Python 3.9, and that will be soon available, and Python 4 is going to be soon available. Basically, whatever there's a major release, they are just doing a lot of features that are introduced to you. If it is a minor, they might just fix some bugs and other issues. They will just send a minor version of it. And then maybe they might just add on to certain modules, and that is also on the minor. And then Python.org has the documentation. So if I just click on Python docs, it takes me to docs.python.org/3. And as you can see here, the Python 2.7 is end of life. But Python 3.10 is in development, and this is in pre-release. And the stable version that we are using is 3.8.5, and that's the one that I upgraded mine last week from 3.8.3 to 3.8.3 to 3.8.5. And as you can see, when you do Python -v for version, you could also do dash version. That will also show you the Python 3.8. You could also type in, because this is Windows, you could type in exec for executable. Since it's everything with extension of executable.com, which is binary command line binaries that will work. You don't need to put the extension; automatically knows that is there. But if I do the extension, it will still work. But the extension has to be .exec. If I just type in exec, if I just type in .com, it's not going to work. If the extension like CMD is .com, then when I open this one, it opens another terminal. Now, every time I type in CMD, it opens another shell, subshell, or another command in Windows. So if I just type in exit, it just exit out of this one. If I exit again here, it exit from this one. And then now if I exit, it will close the whole command prompt. So I open another command prompt just to show you, CMD command. And then right here, if you just want more privilege, you right click and say run as administrator. When you run as administrator, you're able to install software. You're able to install software, and then the important difference between running with more privilege versus less privilege. When you run any command on Windows with selected administrator command prompt, and that I want higher privilege, you're dropped into this Windows System 32. Notice if I just go open up a regular command prompt without that, the prompt header information, it just says command prompt, and it is select administrator for the administrator privilege. This one, it drops me to my environment for the profile that I'm having on this one, Wahid. So if I just look at the path, this is the path that has it. And then notice that the version that was Python 3.7 is there. But because Python 3.8 is prior to that one, so even when I'm logging in as Wahid, if I just talking about this one, it says that 3.5 this. But if I just cut and paste this information right here, or go to that directory. Let me just cut and paste that information. So edit, copy, paste, edit, paste. Okay, it's not reading it or what? Let me just do it one more time. Script, edit, copy, and edit, paste. So when you do that one, if you, let's say I want to do just CD to that one, change to that directory. Now I'm there. Now, notice there's a lot of exec, and one of them is python.exec. So all the binaries that on Python provide on that one is, I don't see Python here, but I should have it under a different directory here. Let me just see what is Python there. So right here is on the main directory is python.exec. Python.exec, if I type in python -v here, this is going to show the previous version, 3.7. So if I do /python and -v, it will say the same thing. And then if I do .exec, so I'm just saying relative to this path that I am, make sure that you run that one. But since I am on this directory, my path, it just says, my path, it says that, sorry, my path, when you do this, when I type this one by mistake, it already assigned my path to an incorrect level. So now if I just say this, it just doesn't, it actually dropped me to Python, which is okay, 3.7. So it's still my path is fresh, but moving out of this environment and then CD to, let's say, the script directory, all the scripts, and you can see that pep is there, pep3 is there. This is a Python installation packages, and Python index packages. Index packages is like pep list will just show you what is currently available, and then you could get other modules that are not available. You could do a pep install on it and pep search for it. So all of these modules are available for you to do it. I'm going to be dedicating a session for pep so you understand how to load modules that are not part of the development environment that you already installed, and you go from the website and download it using pep. So at this time, if I exit out of this, notice that I open another CMD. Even though my path was automatically changed last time, now if I just look at my path, it is back to original. The reason is back to original because on the control panel, under the system environment variable, I have already said that these are the path to be added on in addition to whatever is on Windows. And so this is already on the system. It's on Unix. This would be on your .bash or C and etc profile files. So this automatically comes in every time you open a command prompt or a shell prompt. Let's just, if I just do this one, python-v, because this is the 3.8 is before 3.7, this will just come out as 3.8. So that's also important. In the path, the reason it's called path, it just traverses through the first directory structure. If it finds that python.exec there, it will just run that version. Since this one is after this, it will not run it unless I just go specifically to that directory. Same concept is true about Unix. So I will show you that as well. Let me just open a shell on Unix as well. as we jump in back and forth between different operating systems, I show you some more examples on both. So if you're a Mac user or Linux user, you're not kind of stuck to say, how am I going to write my first Python program using a Mac? And so I show you on both. And Mac is based on BSD, Berkeley Software Distribution of Unix. So if you are using Mac, basically it is the same as Unix. And Linux is similar to Mac and Solaris, Unix, and other operating systems that are Unix based. So Linux, this one is a Linux version of Linux Mint. So if I just go os-release, you see, let me just minimize these other windows, and I could maximize this window. You see only Linux. So in this one, if I'm just using Python-V, this one by default is 2.2.7, 17. So if I just want to use Python 3-V, this is 3.6. But notice here, I don't have a command called path like Windows. If I just type in path, it just says, that one is not there. Do you want to install something like that? And then these are the options that it finds. And then in this case, I say, no, actually, I don't want to install any of that. Or what I was looking for is the variable, environment variable called path. So when we are talking about variables, you need to understand there's Python variables and there's system variables. So path, in this case, is to get the value of it in Unix, you type in path with a $, but path is actually all uppercase variable. So if I just type in lowercase, it's not gonna do it. But the difference between Windows and Linux or Unix and Linux are case sensitive. If you declare a variable called, let's say x is equal 1, then you say echo $x, then you assign that one. But if you say uppercase x is equal 2, and then you say echo $x, is still gonna show that. Now if I do that uppercase x, it's gonna just say this. So and the DOS or Windows operating system, which is based on disk operating system, originally was called DOS. If you do echo percentage, and instead of $, you say percentage, whether you do this path or you do this path, uppercase, it will just still do it. Because on Windows, it converts everything in lowercase to uppercase before it executes it. On Unix, it doesn't. It just is case sensitive. So you have to be very careful when you're working on it. When you're inside Python, okay, if you're inside Python here, and then let me maximize this window. So this is inside Python and then Windows environment. If you look at the path variable, for example, I could just say import sys, the sys module, and then on sys.path, you could see all the path. This is based on my Python version. So sys.version is going to give me the Python 3.8.5 version. The sys_info version._info will give me the major and minor release of Python, all that information. So in order for me to get help on the sys module, what commands are available, what built-in methods are available, what attributes and properties are available, then you could just write dir for directory, and then that object. And this object is a module. So if I say x is equal 5, and then say x, and then in declaring this variable, I just declare the integer, the data type. Now if I do a type x, it tells me this is integer. Now if I just say f for float, and then I say 5.5, 5.9, let's say. I say f 5.9, and then I just print f. It is going to show that, and then if I do type of f, in this case, that float is float class. That f is a float class. So if I just do a print statement and then say, let's say f, I could get the same value. And then if I just want to add, let's say 5.9 times 10, multiply it, you will see that it multiplies it with 10, and then just that one. If you want to use the addition statement, I could do that one as well. So printing those statements. Also, what is available on that floating points? I could get this from the float, like similar to this, but because I have an object of type of f, which is a float, that is also a data type of same thing as this. You can see this is a type, and this is an object of that type float. So if I just do dir of f, I get similar methods that are available for both, right? So now if I just have this, all these underscores method that you're seeing, they are called dunder method. And the way it is written like this, dunder, okay, which means double under. So you can see there's a double underscore on both sides of the variable or the method. In this case, let's say if I want to add a floating point number, I could do like I did here using that method, which is the operator is overloaded by object-oriented concept, or I could just say float f dot underscore underscore add, and then underscore underscore, and then put the value 10. So my float was 5.9, and now I should get 15.9. That's how these methods are available. Like this one, it will return an absolute value of something. So if I just have an x there, let's say x is equal 5, and then dir of x, now you can see if there's an absolute value of something, then you can say dir of x dot underscore underscore absolute value underscore underscore, and then use it as a method. Use it like this. Sorry, I meant to print it, not dir it. Print. So this one is the object, and then now I'm going to use it as a method. It will return. But x is already 5, it's a plus. So if x is equal minus 5, now I run it with this. So if I just print this one, it's going to print minus 5. But if I just print the absolute value of it, it's going to give me a positive number. So those methods are pretty nice, and this dir is similar to the other one. So a lot of these commands we will be using, like Sizeof, for example. Sizeof is going to give you a storage for a data type. For example, x is an integer, so if I say x dot underscore underscore Sizeof, and then get the size of that storage is 14 bytes. Now if I just create a string called a name, and then I assign it Wahid Lutfi. So now if I say type of a name, you can see that name is a string. And then by default, what if I just have a character, name is equal just one character, W, okay? Notice the difference between this. So this is one character, and it's a name, but it's going to define this one as a string. So it is a string class, and then so is name. Okay, so now Sizeof n dot underscore underscore Sizeof underscore underscore with the method. So and there is a difference between when you don't put the parentheses versus you put the parentheses. When you don't put the parentheses, and it is going to show you the object and give you an object ID number, say this is an object, and what do you want to do with it? And now I want to print out the value, the size of this one. To do it, I have to do it as a method. So now it shows this. Now watch, if I change this one to name, it's going to show more characters. So the reason it's showing more characters, and by default, the first character is 26. The next character is 27, 28, 29, 30, 31, 32, 33, up to 36. So if I just have n is equal 1 character, now I'm going to say n is equal 2 character, Wahid, and that one, then the size of n now is 27. So that's the definition, because the storage has to grow and store 1 byte of character. So 1 byte by default is 1 byte. So if I just change n again to, let's say, change it to this, now it's 3 bytes. So 26 plus 2 is 28. Now size of it is going to give me right here. Size of it's going to give me 28. Okay. So let's see what we need to do. Data types, we're talking about variables, right? So in this case, variables we're jumping into different data structures and different methods. And everything that I showed you here is kind of like an object-oriented kind of concept or methodology that we are using here. What we are doing is the object name is, in this case, is n, which is a string. What you can do with that string, and then n is dot this attribute and this method in this case, and we're going to just do it. Or the absolute value is another method that returns the absolute value of that object. So if I just say print name, it's going to say name Wahid, then I could just also say print this one dot upper, and then just use it as a method, and then it will change everything to uppercase. That object that I'm doing here, name and dot lower as a method, is going to change everything to lower. And then the same thing with, let's say, capitalize, capitalize. And then it's going to change the first letter to a capitalized letter. So print a name itself is there. So name dot split. Let's say you could just get a tuple. This is you could get a list of 2 elements. So if I just assign my name, declare a variable called my name, and then assign a name dot split, and then split those ones. By default, if you don't give a argument to the split function, by default it uses a space as a split character, because right here is a space, so it splits it into a list of 2 elements. And then the first element, Wahid sub-0, my name sub-0, in this case would be Wahid, and my name sub-1 would be Lutfi. So now I assign this one, which is this list, into another variable, my name. So my name now has a list of this. If you look at my name, it's a list. And if I just say print my name, it will print both of them, but my name indices sub-0, the index sub-0, it has indices, which is more than 1 index. So if my name sub-0 is the index of the first element, it starts with index 0 until the last element, and then it just goes through to get the output of it. My name sub-1 will be there. And if I just want to have more than 1 character, let's say string 1 let's say I call it my S for my string. My S1 is equal, this is long script which shows the power of a string method in Python programming language. Let's say I just do that one, and then let's say the type of my S1. So I declare the variable and assigned, this is assignment statement, assign this string, long string to string 1. So when I do and I say print the type, and then I could get the ID of it. Each one of them have a unique ID also. And then ID is basically how it identifies that as a unique object in the code to just reference it. So when you copy an element to point to that one, if it is the same ID, normally they are holding the same memory space or data structure in memory. So when I'm doing my S1, now with my S1, I could do a lot of things. My S1 dot, let's say I change the, all of it to uppercase, and then you can see that it changes. But as I'm changing it, I could change it again back to lowercase. So this aspect of object-oriented, you could change it to anything you want, capitalize. Okay, so I could do that one, but the other is like you see that only T has changed, everything else is there. So these are examples of methods, nested methods that you could manipulate with this object. The string is my S1, but I change it to uppercase first, then I change it to lowercase. So that's unnecessary. You don't want to do that one. If I wanted to do only that, I could just do this capitalization. That's good enough, and it would have done the same thing. But if I wanted to change it to lowercase, there I didn't need to just do capitalization, lower case. So since I'm sorry, lower, and just not lowercase. So a lot of these methods that are available, like my S1, you will see with using the dir command. And then, for example, if I want to just strip out the last characters, when we go into string session, when I'm covering a string, I will show you all these other methods, because I just don't want to just be dedicating the whole class to a string when I could cover more variables and methods and strings and manipulation and other things that is already the agenda of, for the agenda of today's session. Okay, so why I was doing this one, okay, so now if I just do my S1, and then I want to just split that one, my S1.
Can I ask a real quick question? I'm sorry to interrupt.
Sure.
Earlier when you were talking about methods, you had several methods on one of the things that you were doing, and you said it was nested methods, right? You said that is that a bad practice to be in general, or is that something that is that just generally a bad practice, or something that in that instance is a bad practice?
No, there's a programming language in called Lisp, L-I-S-P. It's written like this. Basically, it was object-oriented programming, and that was used mostly, and is still used on some schools. They still want to teach you for artificial intelligence kind of programming. It is a function within function. So if I want to print something, I say print, and then I could just do type, and then I could do cast float, and then cast integer, and then cast a string, and then just say, let's say 5, right? So now I started with this. I want to do this 5, I cast it to a string, then I cast it to an integer, then I cast it to float, and then get the type of it, and then print it. So now for every method that I used, this is a string method, I need to close the string method here. I want to just explain to you a little bit detail of what's going on, and then that way I'm clear with what I was saying earlier. So I'm doing string, and now I close it once, and then I close it for integer, I close it for print, for float, and I close it for print. So now it says a string is not defined, and then this one is true because a string is like this. Now notice that I converted this one to a float, but these were unnecessary, right? Why, if my intention was to just change it to float, why did I change this one to a string first and then? But there are sometimes the work that you're doing is required to do that one. So if it is required, maybe the value of the variable that are coming, you don't know. If the x is equal 5, and then you're doing this as x, say whatever x was, just you could just say, sorry, you could say convert it to float like this, and then get rid of 2 of these, and then just had one more. So x is 1 right here. Okay, so you could have just accomplished the same task here with just using float, or the above command here, this one, sorry, one more, and this one is string. You could do that, and then you don't have to do this 2 part when you mean just to convert it to that float, and then print that one. One more bracket. So this is 2, 3, yeah. One more bracket, that's what it's missing. So the conversion, when you're doing a method, it's not a bad practice programming in general. It is not a bad idea to do it. But on the example that I was giving you here with the string, I was saying that if my intention was to just change it to uppercase, why did I have to change it to lowercase? That was just more computation when I didn't mean to do lowercase, right? So if my intention is to get this value at the floating points value, why do I have to convert it to string and integer? I didn't need to. But there might be situation that you're manipulating with complex numbers, right? Complex numbers that you say, I don't know, sometimes it might be integer, sometimes be a string, and sometimes it would be this. Then I'm going to cast it to float. If it is a variable, you say, okay, whatever variable is, I'm going to just convert that one to float like we did here. So if I just have a string here, notice that my S1 is a string. I could not do a float on my S1 because even if it tries to do it, it just doesn't know how to convert this string to a floating point numbers. So it does not make sense. But x is equal 5, and if I just say float of x, I can convert it to that number. And then if I just have this f float and this, I convert that one to integer, I can convert it. So conversion from one class type to another one has to make sense. And then also the method that you're using, you could have 10 different dots and 10 different methods, but it has to make sense. And the concept that I was using, it did not make sense to change something to lowercase, to change it back to uppercase. As a simple example, let's call it name is equal Wahid. And then I say name.upper. I want to do that one. So now I could say lower. So as soon as I call it lower, it's going to change it. Then I could do back to upper. So no matter how many times I could, upper. No matter how many times I could go back and forth, it is just more computation. That's what I'm saying. So If my intention is just to do it in lowercase, and then I need to do only lowercase right here, one time. Why do I have to change it to uppercase, back to lowercase, back to uppercase? That kind of information is not needed. But there are times that you say, yeah, change everything to uppercase, then do something, split it. And then, so like for example, let's say the my S1. My S1 is everything is there. You could just say my S1 dot split, right? And then you say, go ahead and split it, and then it will just put it into a list of all elements. So if I just say, no, I actually wanted everything to be uppercase before it puts it into this element. So then I could just say dot upper. Now, dot split. So in this case, it did not make sense because this is a list. A list does not have a upper method. If you just see it, I say type my S1 dot split, and then as soon as you print that type, it's a list. And if I do a dir of that one, there's no method associated with list called split. You can see that it's not there. So if I wanted, my intention is to accomplish that task, I could just say, instead of doing a dot upper here, I first assign it into another string or another list. So I go say list is equal 1, and then I say, now L is already pointing to this one, and then L sub 0, for example, if I want to just change L sub 0, which is the first element of it, and then I just say dot upper, and that would change that element. So now if I want to just accomplish the same thing, notice if I do L dot upper, it's not going to work because this is upper method is not available for the list object. So, but for each element of the list, because it's a string, I could do the upper. So now if I want to traverse throughout this statement, I need a for statement. So in order to do this one, if I just say for item, which is the index and element of L, okay, I could just put this one as a start to end. This is a more kind of like a syntax that when I teach you a list, you will do it. But for now, just learn that L is a list, and so I could do this one as well. So a for statement, 1, 2, 3, 4. Now I'm a 4 element out here. I could just say print L. If I just print this one by itself, notice that it's gonna give me the same list there, right? But I didn't want to do that one. I didn't want to print that element. So I wanted to do this, print item. Each item, now I'm getting these items. But then my intention was to just print it and then at the same time change it to uppercase. So then I could say for less this, print item dot upper. Now I'm just using the method upper properly. And so that dot is actually a good operator that for that object with methods, what do you want to do it? And again, if my intention is all to change all lowercase, I don't need to do dot uppercase first and then dot lowercase after. So I could do the lowercase one time. That was what I was referring at that time with using something to convert it, and you're just basically telling the computer to do more work for you unnecessary. But if your intention is to change it to lowercase, just go ahead, write the lower function. Why change it to uppercase, then change it back to lowercase? But there might be intention for searching algorithm that you say, well, I need to make sure that it is case sensitive, and I want to just read it the way I want to read it. And no, this everything is coming with Windows. I want to change everything to uppercase every time it comes in. Even if it's uppercase, I want to change it to lowercase. So you could use those methods differently for different purpose. Did I answer your question, or and there's still clarification?
No, I got it 100% actually. Just
Awesome.
do it one way was way more work. Well, it was more work that is totally unnecessary. But yeah, I'm
Yeah,
100%. Thank you.
awesome. Thank you so much. Thank you. Thanks for that question. It was good that if I wasn't clear on something in the first place, please correct me, and then I'll just make sure that you understand what I'm saying. Sometimes it is a first class of computer programming. There's concept of the terminology, syntax, semantic, and as well as the way I explain it. So if I'm not clear on something, if you ask that question, I would be more than happy to and just clarify it. Thank you so much. So we were talking about variable declaration, and we used, for example, a string, my S1, to practice. We used X for integer, we used floating point numbers, name, and everything. So when you assign a variables, normally in Python, you could just add up numbers, and then Python could work like a calculator for you. It doesn't matter what you do. The operator that you're using here or just basically helping you. So like if I do 12 times 3 or 12 mod, which is the remainder, is going to be like, let's say I do 5, the remainder is 2, and then 9, the remainder is 3, and so on. So a lot of the modules and functions that are available for you, the operators, there's a lot of different operators and that you do some expression to do it. And while you're doing this, you could also do like a calculator, or you could do a condition statement. So if you say 5 is equal 5, if that is true, yeah, it's going to return true. If I try to say, and this is the difference between semantic and syntax. So if I just say x is equal 5, it is going to be working fine. But if I just say 5 is equal 5, the programming language, it says, oh, you want to assign the variable 5 to the number, integer 5 to the integer 5. This doesn't mean anything to me. So it's going to say cannot assign the literal number. But this was my intention. Rather than saying assignment, I wanted to do a condition. So the semantic in this case is logically you're doing a two operand with operator of equality. So you're saying a Boolean operator saying that whether this number is equal that number, and that is going to return true because that is good. This. But if I say is this number equal 5 is equal 4, and then it's going to say false. And if I just compare two true values with true value, it's going to do the same thing. It's going to return true. And true and false is not going to be the same, so it's going to be this. And then false and false are equal, so it's true. And then sometimes T and F is just the letter that you're comparing, for example, and that is not defined, right? So if I just say T is equal the string T, and then F as a string F, then I say compare the two, it's going to say it's false because T is not in there. But if the value of T is, I say T is greater or equal symbol. So T is coming after the letter F, therefore it is in ascending order. T is greater than, that's going to return true. If I just say this is F is greater or equal to true, that's going to return to false. And then if I just say greater than is false, but is a less than sign, is going to be true. So a lot of the equality symbols that we're looking here, comparison, could also apply to the numbers. So you could say 5 and 10. If 5 is greater than 10 is false, and greater or less or equal is true. So it is not equal, but it is less than. So that is why less or equal in this case is going to return true. What do you do here? You could do also a if statement. The same thing, like if I say 5 is less or equal to 10, then do something. Say print and the number 5 is either smaller or equal to 10. So since that is smaller, we know the fact it's going to print that one. The statement that I'm doing here, the if statement, has to semantically make sense that I could say something. If I just say here is the 5 and the number 5 is smaller than 10, then it is going to definitely make sense, all right? But what if I just don't know what is assigned to 5 and x? So if I say x is equal 5 and then y is equal 10, now I don't know the two numbers. I'm going to do if x is less than 10 than y. Go ahead, do this one. Now I have to say the number x, in this case, right here, the number x. So I'm going to show you two ways you could do. You could say right here x and then comma y, and then you just, these are placeholder for those two variables, and then print it there. Notice that it just says the number is this, because I just did not put this placeholder in the right place, so I had to do two different syntax. To correct that one, you do this: if x is equal this, you could just say the number, and then close this parenthesis, put x here, and then start here, and then close these two. And then just do that. Sorry. One more type here. Right here, when it says x is, and then you put the comma here, and then that would just say the number 5 is smaller than 10. But Python is much, much smarter than that one. There's, with Python 2.2.17, we use the format method. And then they use that one that as f a string with 3.5 and a 3 point, with the 3 point up, 3.6 and up. So how that if statement works is going to make your life simpler than just this. So this is how you do that. You would say if print this, and instead of doing all this thing, you could just say F for the print. You could do a single quote or double quote, and then right after that one, you just say the number, and then put a brace here, and this for the first one is smaller than the number, and then put another brace for y and close it, and then right here you put x comma y. So this will just print there. If a string, let me just take this one out. Sorry. Okay, so I need to do and then there's no more bracket here. So let's see what, oh, sorry, my bad. I'm thinking some part of it as with format, some of it is with this. So you do this, and instead of putting this, it is just you put X and Y inside this as $, and similar to like Unix scripting or something. So then they will just replace, this is the placeholder. So X and Y, you're just doing it, the number 5 is smaller than the number 10. You can see now if I just say, let's say X is equal 10, and then Y is equal 10. Now I run the same code. Syntactically, this is going to be okay, but semantically, this does not make sense. So if I just print this one, it says the number 10 is smaller than the number 10. It is not. So this wording is unnecessary in this case. The wording has to be matching the condition and that there. So remember that earlier we were saying that the number X is, we could say, is either smaller than the number Y or equal. So in this case, that makes sense. The number 10 is either smaller than the number 10 or equal. And since it's equal, we are doing it. So that kind of comparison operator is there, but semantically, what the statement that you put, make sure that it makes sense on that concept, so it doesn't say something that is not completely math. Because when we do manipulation of variables, we're basically doing some kind of expression. Like, for example, if I say z is equal x plus y, that's now z has the value x is 10 and y is 10. So automatically z get an expression there. I could just do z this 10 times 10, then I get the 100. And then if I just import math function, let's say, or maybe 100, if I just say z to the power of 2, then I could get 10,000. And then z to the power of 4 would be a larger number, and z divided by 2 would be 50, so on. And so now if I just say import math module and then say dir of math, you could see a lot of the functions that are available for math. And I could just say, okay, math.py, math.epsilon value. So a math, for example, dot power function of 2 to the power of 10, 1024. It will give you, and then math to the power of 8, 256, right? And that's like 1 byte long, 256. So let's say math dot square root of 100. Let's say math square root of 100. And then if I just want to use a different method, like earlier we were saying, I want to do power or 100 to the, 10 to the power of 10 to the power of 2. That is 100, and then get the square root of it, I still get 10. So this one is one example of returning 10, and this is another example of this. And then maybe I could just say, let's say 100. So I'm going to do this to the power of 4, and then divided by 2. Okay, the power of 3 divided by 2. Okay, so the divided by 2 is the different number, you get it, but different computation, obviously it has to make sense what you're looking for. In this case, I'm looking for, let's say 1000. The square root of 1000 is 31, and if I just say don't give me the square root and then give me math.power of that one, and print it. So that gave me 1000, and then divide by 3 or divide by 100, and it should give me 10. So how you want to calculate these ones is up to you based on the formula that you're doing it. But assignment statements and methods passing on with the arguments or the keywords that how you want to use it. So if I'm inside Python, how would I help? This is, I get help by looking at the help function. And then if I'm looking for like keywords, I could just type in all these keywords. And remember we were experiencing with if statement. So if statement, it has an assignment statement and some suite of instruction commands, or other expression that you put. There's a LF part and there's else part and so on. So if I just go say, okay, how do I know this one? How do I execute it? I press enter here, say if 5 is greater than 10, then say print 5 is greater than 10. Okay, so I just could do this and then say else, do this part, say print 5 is smaller than 10. Maybe in this case, logically, it makes sense 5 is smaller than 10. But x and y, if I was doing this x and y as example, x is equal 10, y is equal 10. So if I say if x is greater than 10, then print let's do the x here is smaller than y. Else print is greater than y. Then y. And then in this case, what do you think is going to happen? X is 10 is greater than 10. That's not going to be, so it did not happen to this one. It automatically jumped into the else part, and 10 is not greater than 10. So 10 is equal to 10. Then I had to do some more checking on this Boolean operator. So in order to do this one, let's say say if x is greater than y, which is 10, then say print if x is this, print is greater and then 10. So I'm going to just put the placeholder here. X is greater than y. And then do a LF part. Okay. I say LF x is less than y. Okay. And then do the print x must be smaller than, as smaller than y. Now I'm going to do a else part. I don't have to check for more. I say print and I say the value of x must be equal to value of y. So in this case, we compared already the x and y less or equal. We don't have to check for the equality because that number, so the x is 10 is not greater than, it's not going to return this statement. LF is going to check it's not less than either, but it is equal, so it's going to come to this else part and it's going to print the value of x must be equal to the value of y. And then since I just missed the f here, it did not replace it. So let's just do that one with same syntax and say if x is greater than y, print x is greater, and then else elif and this, and then print is smaller, and then else, and then I just put the must be equal, and then I put the f here as a function, and then now it just prints it. They say the two numbers must be equal. So some of these equality operators that are comparison, when you check for conditions, you say if this condition is true, do this one. If this condition is true, then do this statement. If this, sometimes more than one statement could be also executed. I'll show you more examples of that one as well. So if I just go back here at the help, and then in help, you could just type in like, let's say, if statement, you get the syntax, for statement, you get the syntax of how you use a for statement and read it and then practice. Some of it, it also already gave you the examples of how to do it. So in the while statement, you could do that. If you just say math modules, so just give me the math modules there, it will give you help on it. And if you type in a topics with this, you will get a list of topics that you can learn. If you type in modules, it's a bigger list. All the modules that are there, including math and sys and ops and NumPy, everything that are loaded on the system, you could get help on them. So by typing the module name, if you see it, for example, if you just look for the float, you could just type in float or integer. These are topics that are discussed here. The data type that are there, integer, string, and list, and tuples. Each one of them you could get help. A lot of these modules, like for example, random, for the random number generator module, it will just show you the module that are available for you and all the methods that are there. And so when you do this one, if you say OS module, for example, it gives you all the OS modules and whatever method you could do with it. So if you say, well, I learned a lot about OS modules, I want to just do it from the interactive. You could just say import OS, and then dir of OS, you could see a lot of these methods are available to you, like make directories and get the name of the object os.name, we'll just say nt. And then I could just say if os.name is equal this nt, which is for Windows, os.name is nt, for Linux is os.name is POSIX. Same thing for a Mac, it's POSIX. So if you say os.name is equal nt, then you could just run os.system module, system method, and then do a system information info, get the system information on Windows, and then again do a os.system, and then run a tree command, let's say tree command. This will just run a lot of commands out there, but you could just get there, say os.system, run the help command to say, for example, help in general. You want to get help on, let's say, on the tree itself, you could do that one, or help on Xcopy, for example, to just get that information. You could get that, and then say, okay, I did that one, all of that, but let me just, that's good enough. I want to just clear screen afterward. I don't want to do it here, so you could see the screen. And then in this case, if I just do that, it will just run these commands. Say, okay, running the system information right now, then after that followed by the tree, followed by the Xcopy. And see, tree is running. So this is passing all arguments to the operating system and just manipulating the data and getting information from there. with the OS module, and then the method that we use is system. With system, every command that you type in on Windows, in this case, you could run that one as well. Because the os.name was NT, it successfully completed that list of methods that I passed on. If I was saying os.name is something else, then I would have to do that part. While this was running, I'm not gonna terminate it, and because at the end it's gonna give me the help on Xcopy. I will show you on Unix the same thing. So if I just say Python 3, go to Python 3, and then I'm going to say, let me just clear my screen first, so you see something on the top rather than, so I could do like something like print, as simple as a new line character times 50. I could print this one, this line, new line character. If I do it by itself, notice if I print this by itself, print a new line, it's just going to give me a blank line. But if I multiply it to 50 times, it's just going to clear my screen. So that's an easy way to get the information. So if I say import OS, OS, and I get the module, then I say, oh yeah, I got that one. Now let me just clear my system. I could say import OS dot OS, and then say OS dot system. And then since the OS command is clear, I could do that one clear. And then that would do this. And if I just do this CLS, which is a Windows command, it's not going to work. So in this case, I say, what is os.name is going to give me? Os.name is going to give me POSIX. Since it's POSIX, I say if os.name is equal, and then the word POSIX, and then I want to run two commands, for example. One command is saying that os.system get me the uname minus a there, and then followed by the os.system, and then give me the calendar for this year, calendar 2020. I could get that entire calendar, or any other date I could say. I could also use the calendar with some month in front of it, and I get the month of it. Or maybe 9070, whatever year that you want, a birthday of your friend or yourself or some family members. You could just say what day that person was born. Let's just say I want to see something like January of 1970. If you are looking at that year, which was the epoch for Unix, 1970, that is the start date for Unix. So if you look at the epoch calendar for January, you could see that what day was the first day of January, or what day was the last day of January, or what day was 15 or something. So if you do this one, and then you could say os.system. At the end, I'm going to do clear, but I want to do a sleep, let's say 5 seconds before it actually clear the screen, so we could see that information. Then say os.system, and then clear command, okay? And then I could also have an else part here, say lf os.name is equal, and then I say nt. If it is nt, then I want to just clear the screen and don't run any commands. So then I could just say, if it is there, nt, then do this os.system and run the clear screen command. Because the command for Unix is, or Linux is clear, and then on the Windows is CLS. So that is why you're comparing the os.name to just match out different syntax. So at this time, if I just want to do this one, what if I just do else part? else I want to just say, no matter what operating system we have, HPUX, Sun OS, and then DECOS of one, and some other operating system that are VAX, VMS, or anything, I want to just clear the screen, my way of clearing a screen, then you could just do a print, the new line character, that's Python. This is like similar to like Pythonic way of doing it, 50. That's one simple line, and that is going to clear the screen for you and there. So this one, it's since it's Linux, it runs the Unix command here, and then it does exactly what we wanted to see. It gave me the uname command, then the calendar, wait 5 seconds, and then it executes it. But because I did not write all of that in one line or a file, then I just lost the information that I did it. So in order to do it, you have to save it into a file. Okay, so I'm going to show you how to do it in a file. So here, for example, if I go to my Python directory, I have already written a clear screen here for my last session with other class that I was teaching Thursday, which is good for this class because I'm repeating the same stuff, even though I'm making the materials accessible different ways by covering it for every session differently, because date information and some other information is a little bit different, and that may confuse some of the students. Say, why is my class talking about Thursday's session or Saturday session? So I did not share that information there. But other than that, the material is there. If you are interested, let me know. I could share that information, provided that you are not going to question the dates being off, professor, and then it throws me off, and I was thinking that I had to attend Thursday class and those kind of things. I don't want confusion. As a result, I'm covering the materials and differently different times. So more CLS dot clear screen. Notice that on this program, I wrote if it is NT and do this clear screen and then type the actual script itself. And notice that since this script is running user bin env, when it is a POSIX, it's going to run the clear command and then cut the cls.py. So if I run it from command line here, I don't have to run it interactively. I could say Python cls.py. And it did clear the screen, then it cat the command. So the POSIX part, this part played here. It just says, okay, os.name was POSIX. It cleared my screen, then cat the file cls.py, which is this program, and this is the content of cls.py. And then notice the user Benny and v Python, right? So here, if I go to command prompt of Windows, and let's see, I'm going to exit out of this one because on the system, I did not need to install anything since my system was already installed. When you go to the Python 3.8 website, 3.8 download that one, basically under the command prompt here under the downloads, you will see python.exec, which is 3.85. Because I had previously 3.83, when I download 3.85, I run this one and my Python got upgraded. So you have to do that one. You just basically run the executable, install Python, and you will have Python version 3.85. If you have not done the previous version, you don't need to upgrade it, automatically done it. If you did the upgrade, that's great. Just will be upgraded as you like. So with this example of this OS module, let me go to store fall semester and go to lecture. Okay, so this command, if I just do a clear screen here, it will do this, and then I type in dir for directory, and there's a program called cls.py. So if I look at the content of that one is for Windows. And notice that instead of shebang, user Benny, and v Python that we had on Unix, this is the only line that is different between the two. On Linux, you have shebang, user Benny, and v Python, which you put on the first line of your code and say execute this Python script. This will tell a Unix script that this is the list of the source code is coming is a Python code. And then the same thing here on Windows. This is the first line of code that you put, and that tells the Windows operating system. The rest of them is Windows Python, because this Python.exec will just run, in this case, 3.85, this code that follows. These are all common. Everything you put a pound, it's a common. You could also use the double, triple code string for documentation purpose, and we will cover those as well. But in this case, I'm having three line of comments, and then load the OS module. The rest of this information is the same. So here I am writing a function to declare a function called CLS with no parameters, no arguments are passed, no parameters. In this case is you say no parameters. In this case, you say no arguments are passed. Argument is different terminology than parameters. Parameters is when you say a function that takes X, Y, Z arguments, 3 arguments. Sometimes they're position parameters, sometimes they're keyword arguments that you pass on, but sometimes the argument that you pass that is argument. So if a clear screen takes no argument, you don't have to pass any parameters to the function when you define it. And then use the def for defining it. When you passing the arguments, the argument could come as a value. And that value could be a string, could be integer, could be floating points. And normally, how many arguments you have on a function, you pass on that many arguments, unless the argument or some of the parameters are taking default values. We will cover chapter 4 functions, so it will be clarified when we are in chapter 4. If os.name in this case is nt, which is this condition is true, then it's going to type in this cls.py. Notice the other one was catting the file user Benny and v, and now if I run the same program from command line, say Python cls.py, it's going to just clear screen, and then it's going to type in use the type method. The other one was using the cat function, so type is the right syntax. If I was doing clear command here, this would be syntactically incorrect. If I was doing CLS here, it would be the same thing. So all these problems will be what you pass in as argument, the value of these commands to the system function. The module's name is OS, the function is system. The argument that you pass on here is the sometimes a CLS, a clear screen for Windows, sometimes it's type CLS.py, which is the name of the module to print it, and then sometimes it's just using like other things, like we were just looking at cat or calendar or something else. So all these arguments are there. So like, for example, you have been using function called print, and then you pass on different arguments. 2 + 2, that's a different way of calling a function. So in this case, if I'm just doing this, and notice that shebang and then Python showed this one. And then I could also run this one inside my Python. If I'm right here, all I have to do is say import CLS. This is going to do the same thing that there. Now if I do a dir, and that CLS is also a method that is available here. I could also say, for example, from I could clear my screen again by doing CLS, the module name, the method name. That could also do the same thing. So if I just say dir of this, and I know that CLS is there, now let's say if I exit out of this one and I say Python, the next time I come in and do a dir, notice that this dir is not going to have the CLS. It's going to be everything else up from here. So if I run this command dir, you will see that okay, it lost the connectivity. Okay, so now dir is not going to show CLS, but if I say import CLS, that method, and they run it already, and then now I do a dir, it's going to say CLS. Okay, so another method, a way you could do it is if I just say Python, and then I say from, and instead of saying import CLS, I just want to import only that function, which is CLS function. Okay, so other things that are there available, maybe I declare some X variables, I'm not going to use it, some other method are there, but in this case, I'm just saying that CLS. So if I just say CLS, and then I say from CLS, import CLS, now I just did that one and dir of this, because the only difference now is this addition to CLS. Previously I had to do CLS.CLS like this, and now that's not going to be understood because I did not say import CLS. So in order to use this one, now I can directly call that function, and it will be available. So a type of CLS is going to say a function. Because I'm directly, say, from CLS, import that one. Previously, if I say Python here, and then I say import CLS, and then I say dir of CLS, you see here as a string that it says this is available there, but I cannot tell the type of it. So if I say type of CLS, then it's going to say a module. I'm sorry, you have a question?
Yeah, why, so the rest of, when you do the dir CLS, there's the double underscore over under all the other entries before CLS, and then CLS doesn't. So what's the distinction?
Okay, so if I just don't when I use this, let me show you a couple of things to clarify that one. So when you're on Python by itself, if you just do the Python, by default, all these dunder method, which I was telling you earlier, du under, these are called double underscore method. These are system double underscore method or magic method that Python loads it automatically as soon as you run Python interactively or running Python from command line. So these are available to you by default. If I do a dir of this, this is going to be coming with 3.8. These annotation, for example, with 3 point something, this annotation comes in. With Python 2.2.17, the built-in and doc and other ones are available. So depending on what version of Python you're using, let me just show you here. So if I say Python-V, this is 2.17, and if I just go to Python, then I do a dir, notice the list is much smaller. There's no annotation here. These are system magic method, or also called dunder, double underscore method, that are available. So for example, I say print underscore underscore name, underscore underscore name, it will just say that's a main. So every module that is there, you say, if this is the module, call another method. These are information that's available for you. So if I say print underscore underscore built in, all the data types and the methods and everything that you're learning, your coding, everything is on these built-in function methods. So
between system methods and ones that you've added?
yeah, exactly. So to answer your short answer is the method that or the systems, you don't import them, and by default they're available for you. What you import is the additional modules. So in this case, the clear screen was a module that I added. So once you add it, it's going to be available there for you. You're right. So does that answer your question?
Yeah, thank you.
You're very welcome. So print build ends, and then, so if I just get help on this build ends, for example, print and then help on this, you see that all the built-in variables and methods and all the other ones that are available, it will list you. This is a big list, so I'm not going to go through the list here. I'm going to do a queue for quit and then exit out. But the same concept here, if I go to Python 3 and then do a dir, notice the annotation comes in. So with Python 3, in addition to these built-in variables and other ones, there's also annotations. So there's, if I just do an import OS now, and then now do a dir, OS is also added. So these are the things that by default is not gonna be there. So let me just exit out here, clear my screen, clear my screen and say Python 3. If I do a dir here, notice OS is not there. So if I say os.system and then say uname -a, it's gonna say, I don't understand os.system because that module OS is not there. Since I did a dir, I don't see it. But if I do import OS and then I do a dir, and now it's there, now I go up arrow and then use this uname -a, is gonna execute that command. So if I just change that one to a calendar command to get the current calendar, if I just do who is logged on to the system, give me a date, anything that you want to do, give me the operating system, OS-release, you get those information. Say, I just like all of that, but I just want my screen to be cleared. You could run that one and then just does it. So coming back to command prompt here, when you're just doing a dir here, nothing is loaded except the default ones. These are system methods, a magical method or the other method that are available to you. But as soon as you say import a sys module and then you do dir, now sys is there. As soon as you say import CLS, you say the dir, now sys and clear screen is method are there. So if I just do import OS, dir again, and now OS is there. So now all the objects that are there for the OS and the methods are available for me. I could do like, for example, os.name and get the os.make dir and then just say a new dir, create a new directory and then run that one and then say os run the directory and then say, I'm sorry, I made the make dir and the directory. So I'm going to say OS system and then now notice that I made this directory and the new directory. So I'm going to remove the two directories. I could just say os.system or mdir and say dir. That would do it. And then notice that it is gone. But the new dir, I could also use the command line instead of the, saying the os.remove directory. That method, I could just say use the operating system. if the function is not done, and this system generic command that allows you to remove dir and then new dir, that would do the same thing. Since it's returning 0, meaning that it successfully executed that one. So now if I do a system dir, you see the new dir is not there. So you do see these methods that are available, and then for example dir dot, if you want to say type of sys dot or just type of os dot system, what is this? Is a function, and it is going to say this is the method, and that is a built-in function. But it takes arguments. So if I say let's say dir, it just tells me run that command, but then and the result and that it shows is 0 successful, it's declare the end. If there's a result of this one is not a valid syntax, it failed, but they also return an integer, but that integer was non-zero. So it is a function always return a value, whether it is successful or not successful. So let me show you that one also on Unix. If I just come in here and I just say pwd ls minus l df minus h, I get this command, and now if I say df minus h and put some garbage here that is not returning the proper syntax, then I say echo $sign question mark is going to say in 1. But notice if I run this command successful, then I say echo $sign question mark, meaning the return value is 0, meaning successful. Any command that I type in here, I just, that command executed, the return value would be this, correct. So a clear command there, and then return value is 0. But if I just say CLS, which is a Windows command, and that is not going to be understood. Now I do echo $sign question mark. It's a non-zero. It is a different number. Sometimes it give you -1, sometimes give you 1, sometimes 127. The return value has to be 0 to say this command succeeded or this function succeeded. So in Unix, everything is a file. And then the file the commands that you execute, it returns a value. That value is either successful or non-successful. When it's successful, $sign question mark returns a 0. Same thing on Windows. That if the command is successful, then it's gonna just execute there. But there's no variable, say $sign question mark, to see the value of it there. If it is there, let me double check in there. So I say dir command, and then I say echo percentage question mark. And that might be equivalent to it now. So that percentage maybe is something with the return value there that you could just go on Google and say, let's say, google.com, and then search for, you could search for like string Windows equivalent for $sign question mark. And what is the equivalent on Windows? And see if this one give you an answer. That's good. If not, we don't have to worry about it. Error levels. So the string is really long. It's called error level, and then percentage there. So let's just try that one. So if I just say dir and then say echo percentage error level percentage, that is returning 0. Now if I just say dir and this, and that is not found, then print it and it's non-zero. So equivalent to $sign question mark is error level, the variable. Some of these variables, if you do a set, it's a big list. So nobody memorize all these variables by name or this. But if you're working on the platform, you're expected to know those ones. I never code on this environment of Windows as much as I do on Unix. So it is, that is what it is. If I just run env here or set here, that I get the list of all the variables that are on the system defined, and then I could just get, for example, env and then grep for path, and then I could just get the path there. This is, there's more commands. I mean, we will cover it one at times for it. At this time, I don't want to confuse you with too much detail. So let's see what we have to cover. What time is it? It's 10:12. Okay, let's take a 10 minutes break. Unless you have question, I could answer the questions. And if you don't have a question, let's take a 10-minute break, and then we come back. We will do a roll calls after the break, and then we just basically, so it's 16 people already in. That's good. We could do a roll calls. If you're not attending today's session and last session you were missed, you will be dropped out of this class. I have about 5 or 6 people that were on the waiting list that I added them. I'm hoping that they already signed in, some of them. And if you need to add a drop code that you already are on the system, you're listening to this video maybe online later, because you could watch it, then please make sure you send me an email to just so I can give you another add and drop numbers if the first one did not work. But and if you need the link for the Converse Zoom, I already sent it to you. I can send it to you for one more time before you're added to the class. Does anybody have any question? Okay, great. So no question. Let's just take a 10-minute break. We come back at 10:30. I'm sorry, 10:25. 10:25, and then we just resume from there. Okay, I'm gonna stop recording, and then we could record it again afterward.